What if, and hear me out on this, your very first Python project wasn't just some stupid calculator, or a to-do list, or FizzBuzz? And what if instead you built a text-based RPG game? In this video, we're going to build a game from scratch. It's going to be very basic. It's going to be text-based. It's going to require you to use your imagination. But if you're looking for a fun passion project to build skill with the Python language, this is definitely a great choice. Let the adventure begin. This is one of my favorite labs from our Alta 3 Academy Python Basics course. Let's take a look at what it looks like when it's finished. So when we start the game, we are being told that you can either go in a certain direction or you can get a certain item. We're currently in the hall, there's nothing in my inventory, and I can see that there is a key. If I type get key, two things. You can now see that a key is in my inventory and that there are now no longer any keys for me to pick up. So there's no infinite keys here. And notice I'm getting the message, you can't get the key whenever I try to pick up this certain thing. So if I'm trying to get a life, you can't get a life. So now let's try going in a different direction. If I go south from the hall, I seem to have encountered some sort of death circumstance. Let's fire this game back up one more time. If I go east, I'm in a different room where there's a different object. I can get that object. I can go south. I'm in the garden. What we're eventually going to want to have in addition to a failure is a way to succeed. If I were to both have the key and the potion inside of my inventory when I go back into the garden, now you'll see that I've been able to succeed and win the game. So just from what we've seen so far, here's what we need to create inside of our code. We need to be able to model the inside of a house or a castle or some zombie infested battle yard. It's up to you in the game that you make. We also need to be able to take input from the user about how they can get items or go places or potentially other types of commands. That also means we need to anticipate bad input from our players. We also need some means of tracking the player's location, whether in the hall, the kitchen, the garden, the monster's stomach, what have you. And as we pick up items, they need to show up inside of an inventory. And what we also need is a way to lose the game as well as to actually win at the game. These are just the bare basics, but after we've gone through how this code works, you will see just how expandable it is and how I have lots of suggestions for other cool things that you can try on your own to do with this code. Let's go ahead and start by setting up a few simple pieces of data. These two variables are representing values we're going to need inside of this game. Inventory is at the start an empty list. As we pick up items, we will add to this list, or potentially as we drop those items, we'll remove them from this list. Our other variable, current room, is going to be constantly updated with what is the name of the room that we are currently in. And now here's where things are going to get a skosh more tricky. We need to figure out what is some way that we can model the layout of our setting inside of a Python object. We're going to start off real simple by taking a look at this diagram here. We have two rooms, a hall and a kitchen. And as you can see, the hall is north of the kitchen. We're going to chart this inside of a dictionary that we are going to just call rooms. And inside of this dictionary, there are two keys, hall and kitchen. To the right of those two keys, hall and kitchen, we are going to put all the information that is being applied to those rooms. What other rooms might there be that are connected to it, which we're going to represent like so. We now have some nested dictionaries as those two values. And when you're in the hall, the value of the key south is kitchen. When you're in the kitchen, the value of the key north is hall. So what we're doing is we're representing the relationship of these two environments just by charting it out inside of a dictionary. Let's try what we got so far. If I were to print out I am in the, and whatever the value of current room is, you can see that when the game begins, we say that we are currently in the hall. Now let's try this on for size. What we're also going to do is that we are going to print from our rooms dictionary what is the value of the key hall. We're going to save that to the variable directions, and when we print that out, notice that the value of the key hall is the dictionary south kitchen. Now, watch this. If current room is a variable that equals hall, couldn't I use that variable there? When I run the code again, notice it gives me the exact same output. So we can use current room to pull from the dictionary, where can we go? So what that means is that if the value of current room were to change at some point inside of our code from hall to, let's say, kitchen, when we run this again, notice that now it's saying different set of directions. Dictionaries can be very tough if you are first getting started with any programming language, but they are parsable. And notice that what we're getting back is a dictionary. If I want to get back, all right, well, give me just what is north if I am inside of the kitchen, by adding one more slice onto that variable, notice now all we're getting back is hall. What makes Python a great language for beginners is that it operates from top to bottom, which is not the way that all languages work. Notice that what we're doing now is that we are going to take what the value of directions is. Remember, last time that was hall. And we are now going to overwrite our previous variable current room with our new variable directions. So note when I run this code again, it says I am now in the hall. The value of current room has changed. This is going to be an essential part of how our game as written is going to work, allowing us to update our location in the game as we go from turn to turn. What we need next is some sort of input from our user that will allow us to go from room to room, or later to be able to pick up items or do any other type of action you want to do inside of your game. Input is going to allow us to type in an answer. And because we're putting this inside of a while loop, it means that it's going to let us continue taking turns over and over and over again. Currently as written, this game is just going to constantly be asking us for input over and over and over again. So if you're following along and you get stuck inside of this, just press Control-C and it'll break you out. So what we want to do is we'll be able to turn move into something like get sword or go north. So we need to do a little bit of magic with this variable to make it useful inside of our code. Split is an example of a method. What that's going to do is it's going to take the string that we get back from our input function and it's going to let us split it into two different parts. So if I were to type go north, look what that gives us. It split it apart into a list where the first element is go and the second element is north. The same thing would happen if I were to type get sword. The first element is get, the second element is sword. Now, something of an edge case that we need to prepare for ourselves here is what if somebody wants to get a golden sword? Notice what that's doing is that it's splitting it into three different parts. I don't really want it to be three parts. I want it to be verb followed by object that I want to pick up. So what's cool about the split method is that we can say, all right, here's what I want you to split every time that there is a white space. That's my first argument. And also, I only want to split it just the first time that a white space occurs. So with that small change in place, if I were to type get golden sword, notice there are only two elements in this list now, the verb and then the item that I'm trying to pick up. What we've now done is that we have changed our move into something that we can actually split apart and use. So for instance, if again, I were to type get dagger, look what we're doing here. Move 0, element 0 means the first element in the list, which here you can see is get. Move 1 is the second item in the list because lists in Python go according to index numbers starting from 0. So what we can now do is we can set our first condition. If move 0, that first word, is equal to get, those two equal signs is a Python conditional that means the same as. We can test that by saying that if move 0 is get, then we'll print go get him. And notice that's what happens. Whereas if I type go north, nothing happens because that condition wasn't true. But here's where things get a little bit tricky. Get what? We have to say that items exist inside of certain rooms in order for them to be picked up. So this is another great opportunity to model this inside of our rooms dictionary. Let's add another key that we'll just call item. You could call it whatever you want, but item tells us that it's something that can be picked up. What can you pick up inside of a kitchen? Why, a chainsaw, of course. I don't know where you keep your chainsaws. That's where I keep mine. Don't come at me in the comments saying, oh, Chad, you could have written it so much more fancy if you did it this way. I know you can. This is just trying to be as clear as possible. Let's do this. We're going to add another nested if condition. We're checking if move 1. What's move 1? Oh yeah, it was that second part of my move command. Sword, chainsaw, whatever I'm trying to get. We want to see if that is the same as what item is inside of the room. Follow along with the dictionary logic now. We check that in the room's dictionary, at the value of what our current room is to the value of the key item, is that value the same as what the player said they wanted to pick up? If that's true, they should be able to pick it up. You got a chainsaw, or whatever it is that you're picking up. What I did here is I'm using something called an F string. You just put an F right in front of that first quotation mark, and anything that's inside of those curly braces will be treated as a variable. So when we print this out in a minute, it should say you got a chainsaw, or whatever it is that you picked up. And now we need to put that item inside of our inventory. The inventory list has a method called append, which simply will take whatever is inside of your parentheses and will add it inside of that list. Don't be afraid to throw print statements into your code whenever you need to check or debug how things are going. Let's print out what is the value of inventory to see if we did successfully pick up that old chainsaw. So if we type get chainsaw, nice, you got a chainsaw. But we got a problem. You got another chainsaw. You got another chainsaw. You get a chainsaw. You get a chainsaw. Everybody gets a chainsaw. Yeah, I wasn't looking to have infinite chainsaws inside of this game. Now, of course, there's always multiple ways that you can handle anything inside of Python. But what we're trying to do is that we're trying to make our rooms dictionary model what it is that is the state of our game. And the way that we'll do this, so I don't have to rewrite too much code, is that once you have picked up the item, we're just going to change the dictionary. We're going to take the value of item, and we're just going to change it into an empty string. So when I run my game again, and I type get chainsaw, chainsaw is still in the dictionary. And as a result, I'm adding it to my inventory. But if I type get chainsaw one more time, the value of item is no longer chainsaw, it's an empty string. Therefore, it failed the condition. Therefore, I did not add it to my inventory. But we can't expect our players to read our minds and know that that's the case. So let's add an else. If that condition is not met, else what we'll just say is you don't see a chainsaw here. So if I type get chainsaw, it works the first time, but when I do it the second time, I get a message saying you don't see that item. Cool, so we at least have at the moment a rudimentary means of being able to pick up items and to remove them from the rooms that they are in. Now, let's move between rooms. We're using the same trick as last time, where move has been split. And we know that if the first thing that is entered is actually a verb like go, then we can simply add a condition checking for that. Now, the logic here is going to be slightly different from picking up items. So what we're going to do is we're going to check. If you say that you want to go north, we need to look inside of our dictionary. Is move 1, so north, inside of rooms, current room? If our current room is kitchen, then let's take a look. What is the value of kitchen? It's a dictionary with the keys north and item. Is move 1, which is north, inside of that dictionary? Yes, it absolutely is, which means that is a valid direction to move. And then we can do what we did earlier. We will overwrite the value of current room. And instead, we're going to replace it with whatever the value of that move was. So if move 1 is north and north is in the kitchen dictionary, what is the value of move 1, which is north? Hall. So that means that our new current room is the hall. So just adding 2 print statements there so we can double check our work and debug here a little bit. Okay, so adding these 2 print functions so we can check our work and debug a little bit. When we first start, it tells us what is the value of current room. You are in the kitchen. If I were to type go north, it says that you are now in the hall. It then looped back around in our while loop to the beginning again, and that's why it's printing out you are in the hall as a result of this. And like we did with when we're picking up items, we need to add a condition. Well, what if somebody tries to go somewhere they are not allowed to go? So if we try this again, let's add an else. If I'm in the kitchen and I decide to go east, can't go east, you're still in the kitchen. You can also totally put in directions like up or down or things like that, but our dictionary only has a key for north. So when you're in the kitchen, you can only go north into the hall. And when you're in the hall, you can only go south back down to the kitchen. Okay, so we've got our first 2 commands built inside of our game, but the thing is, no player is going to know what those are, so we ought to add some instructions. To do that, we are going to define a function. A function is a reusable block of code that you can call as many times as you want inside of your script. And this function, show instructions, all that it's going to do is it's just going to print out a message saying that this is our RPG game and that you can type go, direction, get, item, and that's the way that it works. Those 3 quotation marks at the beginning and end of that string mark this as a special kind of string, a multi-line doc string. This allows you to put line breaks like you can see that I have here that when I actually run the game will show up. Thing is that we do need to call those instructions when the game starts. And it's important that we do that at the right spot. I want to call that right here before my while loop begins. The reason why is that now you can see that's printing out once the game begins. What I definitely don't want to see happen is for that to show up each and every time that I type in some new input. Notice if I were to take show instructions and then put that inside of the while loop, then as a result of running this time, notice it's showing the instructions every time. We're getting pretty darn close to a point where you can start putting your own spin on this game, because now we're going to talk about how can you expand the world that you're in. We're going to go from having just 2 rooms, a hall and a kitchen, to 4. A hall, a kitchen, a dining room, and a garden. We're going to put several items inside of each room, a potion in the dining room, key inside of the hall, and we're also going to put a monster inside of the kitchen. And as you can see, it doesn't take a lot. Dictionaries are unordered, so you can add rooms in any order that you want. As you remember from our map, when you're in the garden, north goes back to the dining room, and our dining room actually has 2 directions, where south goes to the garden and west goes back to the hall. So to make our map work, we're going to put the potion item that we said we had inside of the dining room. We are going to add the key item inside of our hall. And in the kitchen, we said that there was going to be a monster. We'll put monster as an item for now instead of a chainsaw. But that chainsaw is a little bit too much fun to lose. So I'm going to go ahead and put that chainsaw in the garden. Perhaps a much more likely place to find a chainsaw. Got to find some way to beat that monster later, am I right? Now, if you're following along with me, make sure that you are really minding your P's and your Q's, or more appropriately, your commas inside of dictionaries. You always have to have commas that separate one item in a list from another, or from separating key value pairs from each other inside of a dictionary. That's just a small typo that I made. Just want to make sure you're not making that too. What our game is now missing is some means of winning or losing. For our first victory condition, escape. Suppose you're able to get into the garden and you have both the key and the potion in your possession. We also need a loss condition, which is just going to be you getting eaten by the monster. For our victory condition, we just have to make a condition. And in this one if statement, we are putting two conditions. We are checking to make sure that the key is in the inventory and the potion is in the inventory. Both of those conditions have to be true in order for this line to be met. And your victory message will be you escape from Alta 3 Mansion with a magic key and potion. The break keyword is what we use in order to end while loops. Remember, as long as this loop is running, the game will continue to run. So a game over will be whenever we break out of that particular loop. So let's test our work. If we are currently in the kitchen and we go north and we are now inside of the hall, we can type get key. I'm going to go east. I'm now inside of the dining room. Trust me. I'm going to go south down inside of the garden. Let's test our work. So right now we're inside of the kitchen with the harmless monster, which hilariously I could type get monster and now there's a monster in my pocket. Now would be a really cool part where we could test what we've done so far. But here's the problem. When I start out, it says that I am in the kitchen. Okay, if I type go north, I'm in the hall. But wait, wasn't there a monster in the kitchen? And isn't there a key inside of the hall? And for that matter, what's in my inventory? I don't know any of these things. So let's add a few more lines of code, and then we'll see how the whole thing is working. Again, so our code doesn't get too bloated, let's put this code inside of a function, because we're going to call this each and every turn, which is going to print out what current room are we in and what is inside of our inventory, and a little bit of fanciness at the top so that it isn't too hard in the eyes to look at. But what about if there's an item in the room? Well, let's check. If there is the item key inside of our current room's dictionary, and then for readability's sake, let's just save whatever that item is to a variable. That way, we can simply print out a message. You see a key. You see a potion, chainsaw, monster. And if that is not the case, then nothing will print out at all. So the name of that function that we just wrote is status. And what we'll do is we'll just call that function at the beginning of every turn, giving us a little status update. I have to be fancy and close that block off after everything's all printed out. There we go. All right, so here we go. I can see I'm in the kitchen, there's nothing in my inventory, and there is a monster. Hilariously, because the monster is an item, I can actually pick him up and put him in my pocket. Gotta catch 'em all, gotta catch 'em all, yeah. Oh, and it's saying you see a, Okay, so here's the part that I could have fixed in post, but I'm not gonna. Let's figure out why this is happening. If we go back inside of our code here, you can see that we are just checking if there is an item inside of the current room. And do you remember what happens when you pick up an item in our code? Right, it just replaces the value with an empty string. So that's why you see a blank is what showed up. So for a little workaround, what we'll do is we'll do it this way. If there is an item in room's current room and room's current room item, full stop. What that's asking is that if that key has a value. Empty strings, empty lists, empty dictionaries, all of those would translate as false inside of a condition. So both of those things have to be true. There has to be an item in the room, and that item actually has to have a value in the dictionary. Then and only then will it show up in our output. So let's try this again. Once more, let's get that monster. And this time you can see that annoying follow-up message is not there. Speaking of annoying, the fact that as I go from room to room that it is constantly just displaying everything in a hot mess on my screen is getting pretty old pretty fast. In a Linux environment like I have here, typing the clear command is a way to clear off your screen. Just remember that for what I'm about to do next. What we want is a way to clear the screen as the game is running, maybe after each time I type in some input. So this is where we are going to import a module. Modules are extra sets of tools that you can pull in and use inside of your code. Here I'm importing the OS or operating system module, because what that will let me do is that I can use one of its built-in functions called system. This is going to make a system call. And remember that clear command, how it cleared everything off my screen? Well, here I'm going to have that command be executed after I type in my input inside of the game. All right, so if we try this again, we're in the kitchen, you see a monster, get monster. Nice, you got a monster and it cleared it off my screen. I can now go north. I'm back in the hall. You see a key, get key. I'm going to go east. Can't go east. That's because I never added it to my dictionary. East dining room. All right, let's try this again. East dining room. Okay, let's try this again. All right, now I'm inside of the dining room. Now remember, we've been trying to work out a victory condition this whole time. If I go south into the garden, I've got the key, I've got the monster, but I need to have the key and the potion in order to win the game. So if I go back north to the dining room, get the potion this time. I need to add on to my victory condition, because at the moment, as soon as you get both those items, it ends the game. Forgot. Now we're going to add the third condition that has to be true. Key in inventory, potion in inventory, and the current room must be equal to garden. All right, so I ran back through the whole game again. I've got all those items. I'm going to go south into the garden, and this time it will actually let me win the game. Now we need to program our loss condition, because we shouldn't be able to just pick up monsters and throw them inside of our pockets. I will get sued. We're going to check for two conditions to see if this monster is going to kill us. First, we need to check, is there an item in the current room? And is that item inside of the current room actually a monster? Then we'll make a nice homage to a much more famous text-based adventure game. You have been eaten by a grue. Game over. But remember, for the game to actually be over, we have to exit the loop. So let's add our break condition. And as soon as we fire up the game here, we are in the kitchen. You see a monster. Why wasn't I killed automatically when I came inside of the game? Well, notice when I left and I re-entered, that was the case. Probably should not be starting the game inside of the room where we could get killed, right? So how can we start the game somewhere else? Real simple. We just change our initial value of current room from kitchen to hall. That way, when I start the game, I'm actually inside of the hall, and if I go south, I'm immediately intercepted and devoured by the monster. You might have seen this one coming, but let's add another victory condition. We should be able to defeat our monster, and there is that chainsaw in the garden. So if we're in the room with the monster, and if there's a chainsaw on our inventory, I don't want to get demonetized. You fire up the chainsaw. Brap, brap, brap. The monster squeals, busts out the window, and flees. You defeated the monster, you win, and then we break out of the loop that way. But of course, we'll keep this else condition that if the chainsaw is not in your inventory, well then you just get old plain fashioned eaten by a grue. Alright, so if we go south, no chainsaw, we are still getting eaten by a grue. But if we were to go east, go south, get chainsaw, go north, go west, go south, then we fire up that chainsaw, the monster hightails it out of there, and we've won the game. Okay, so hopefully we had a lot of fun, and obviously this is a very simple script that doesn't use advanced things like classes and other sorts of really nifty stuff that we could talk about in other videos, but it is definitely ripe for all sorts of additional customization. Here's a couple of suggestions for things that you could try. Add some more rooms to the game. Could you figure out a way to have more than one item inside of the same room? Can you add more verbs other than get and go? Could you have use or kick or jump or whatever? You could add a combat system that you're encountering with the monster. Or maybe the monster is a sphinx and there's all these riddles that you have to answer in order to survive the encounter. And maybe if you don't get it right in 3 guesses, the monster gets you. Point is, there's lots of fun things that you can do. And if you'd like to get a copy of this code as well as a list of some suggested activities, go ahead and click the link down inside of the description. This entire lab, as well as many others like it, are part of our Alta 3 offering, Python Basics. Will teach you everything you need to know about the Python language. And if you're looking to build APIs or whether you're looking to automate networks, we've got plenty of Python courses along that as well. Click that link down inside of the description and try out a 3-day trial for $3. You'll see the exact same environment that I was working in, plus videos featuring this guy that will teach you everything you need to know about Python. Hope you have a lot of fun with that project. Let us know down inside the comments what it is that you would have done differently about how this code works. And don't forget to have lots of fun. I'll see you next time!